So we're told that a guide wire from the top of a transmission tower forms a 75-degree angle with the ground at a 55-foot distance from the base of the tower. It wants us to figure out how tall the tower is as well as how long is the guide wire. So let's start by drawing a diagram. So here's going to be my tower. And it's safe to assume that the tower is going to be perpendicular with the ground. So this would be a 90-degree angle. Here's where my wire is going to attach to the ground and it's going to go up to the top of my tower. So it tells us here that the wire forms a 75-degree angle with the ground. So this guy right here is going to be 75 degrees. And it tells us that the distance from the base of the tower to the wire is 55 feet. So what it wants us to do is it first wants us to figure out how tall is the tower. So that's what I'm going to call X. We're going to find X first. So I know that these two acute angles have to add up to 90 degrees. So 90 minus 75, that's going to give us 15 degrees up here. Is that really necessary to know? No, it's not. But if you want to know it, there it is. So I'm actually going to work with 75 degrees. That's going to be my theta. You have an option here. You can use 15 degrees or you can use 75 degrees. It doesn't matter, whichever one you want. So if 75 is my theta, that means that X would technically be the opposite and 55 would be the adjacent. So I need the trig function that deals with opposite and adjacent, and that would be tangent. So I know that the tangent of theta is equal to the opposite over the adjacent. So I'm going to fill in what I know. I know that tangent of theta, what's my theta? My theta is 75 degrees. I know that the opposite is X, and I know that the adjacent is 55. So I then want to solve my trig equation for X. I need to get rid of dividing by 55, so I'm going to multiply both sides by 55, so that X is equal to 55 times the tangent of 75 degrees. And that would be the exact height of the tower. I can then go in and give a decimal approximation. So again, make sure you're in degree mode. So I am now in degree mode. I'm going to type in 55 times the tangent of 75. I'm going to round that to two decimal places. It would be approximately 205.26 feet would be the height of the tower. Okay? So then the second question is asking me to figure out how long is the guide wire. So the guide wire goes from the top of the tower down to the ground, and I'm going to go ahead and I'm going to call that Y. I'm going to continue working with my 75-degree angle as my theta. I know that Y is the hypotenuse, and I know that 55 is the adjacent. So here, what trig function deals with adjacent and hypotenuse? I could use cosine. I could also use secant. I'm actually going to go ahead and I'm going to use cosine. So the cosine of theta is equal to the adjacent over the hypotenuse. So substitute in what we know. We know that theta is 75 degrees. I know that the adjacent is 55. And I'm trying to solve for the hypotenuse, which is equal to y. So the first thing I'm going to need to do is multiply both sides by y. So I have y times the cosine of 75 degrees is equal to 55. Then I'm going to divide both sides by the cosine of 75. And that's going to leave me with the exact length of the wire to be 55 divided by the cosine of 75. And notice here, a 75, 15, 90 right triangle is not one of our special right triangles. Thus, we can't set up the ratio of sides and find the exact value. When dealing with an angle that's 75 degrees, we're going to have to rely on our calculator to calculate that value for us. So we're going to have 55 divided by the cosine of 55 divided by the cosine of 75 degrees. And that's going to give us our wire length to be approximately 212.5 feet. And that makes sense that the wire should be longer because it is the hypotenuse of the right triangle. Therefore, it should be the longest side in this situation.